Good morning, people. My name is Hannah. I'm a fourth-year geomatics engineering student in ITS. And I must say this is my first vlog because one of my beloved lecturer, Mr. Tanar Guru Pratama PhD, gave us an assignment to explain about the application of hydrographic survey in offshore engineering using a vlog. So, if this video blog is a little bit boring and messy, please bear with me. Let's get started. Hydrographic survey is a branch of surveying that deals with any body of still or running water such as river, harbor, lake, or stream. It's used to define the shoreline, currents, tides, seafloor, depth, or submerged construction. In the other words, hydrographic survey is the science of description and measurement of any features which affect the maritime construction, maritime navigation, drilling, dredging, or any offshore-related activities. Offshore engineering is an engineering that related with the design and construction of structures that intended to work in a stationary position in a deep water ocean environment. The majority of offshore structures are used in oil and gas industry. The application of hydrographic survey in offshore engineering are used for drilling, dredging, rig positioning, or pipeline laying. These are the data produced from the hydrographic surveys. First is multi-beam echo sounder data that give you information about the horizontal position and the least water depth of surveyed area. Second is side scan sonar data give you an image of a seafloor terrain from sonar system. Third is sub-bottom profiler to identify and characterize the layer of sediment rock under the seafloor. From those data, you can have multiple outputs such as bathymetry maps that provide you an XY coordinates and the depth shown by those little numbers, or a three-dimensional model of seafloor terrain from a multi-beam echo sounder and side scan sonar combination. First is dredging. For maintenance dredging, you need to know about the position, volume, and the type of sediment that you need to dredge using the appropriate equipments. The main benefit of remotely operated vehicles or ROV is that they avoid using people in the water during subsea operations. It is piloted on the sea surface from a dedicated boat. It's capable of operating in depths rated to 3,000 meters and at currents beyond the capability of divers. In the video, ROV is used for monitoring the drilling process in the sea floor. An exciting development in the recent years is the autonomous underwater vehicles or AUV, which are not physically connected to the support vessel but are reprogrammed to a specified line plan and then launched. The high level of accuracy achieved will enable the AUV to travel only 2.5 meters above the pipeline. High-resolution digital photos assembled with the mosaic-based technique will provide a complete image of the pipeline. A long baseline or LBL acoustic positioning system are used to track an underwater vehicles or drivers. Its unique system is that they use a network of seafloor mounted baseline transponders as the reference points for navigation. They are generally deployed around the perimeter of a work site. The result is a very high positioning accuracy and stability that is independent of water depth. Generally can be better than 1 meter or even can reach a few centimeter accuracy. That's all from me. Thank you for watching.